This is problem number 12 on the practice problems for test number 3. Find the Taylor series expansion for f of x equals cosine x squared about x equals 0. Hint, start with the Taylor series expansion for cosine of x. Write out the first 5 terms of the series as well as the nth term of the series. So if we were just going to start from scratch with cosine of x squared and we wanted to find the Taylor series, we would need to find f prime of x, f double prime of x, f triple prime of x. We need to plug x equals 0 into all of those. We need to try to figure out what the pattern is. We would have to divide those numbers by the right factorials. We'd have to stick on the right x to the ends. But in this case, we're just going to use something that we already know, and that's the Taylor series for cosine of x. This is on your reference sheet, the Taylor series reference sheet page, towards the bottom. So cosine of x is equal to 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial. That's probably enough. If we need more, then we'll get some more. Okay, so then our problem involves finding cosine of x squared. So I guess all we need to do is replace the x in this blue line with x squared. So let's write that here. So cosine of x squared is equal to, so all those x's become x squareds. So this becomes x squared over 2 factorial plus x to the 4 squared over 4 factorial. I did not do that right. So it should be x squared to the 4th, and this next one is x squared to the 6th. And then it continues. So what are we supposed to do here? The first 5 terms. All right, I guess we need to continue a little bit further here. So that's the first 4 terms. So the next one would be x squared to the 8th divided by 8 factorial. And that's it. That's the first 5 terms. Let's go ahead and deal with these exponents, and then we'll try to find the general term. So 1 minus, multiplying those exponents, we get this. So we have that, minus dot, dot, dot. And then we just want to try to capture the general term. And so if you can just look at this kind of pattern and figure out exactly what the general term is, that's great. If you need a little bit of help for how do I build x to the 4th, x to the 8th, x to the 12th, those aren't just evens, those are, we're skipping some evens when we write those, then you could come back up here to the blue and actually write down what the general term is of the blue. So the general term for the blue is this -1 to the, and then I got to figure out whether it's n or n plus 1, but we'll just say that for right now. X to the 2n divided by 2n factorial. And for example, if I plug in n equals 3, then this guy becomes the 6th power. So I'm looking at this term right here. N is 3, that's a 6 factorial. N is 3, that's actually -1 cubed, which is -1, which agrees, should be negative. So I think we've got the right power there. And then the nice thing here you can do is just replace this x with x squared, just like we did with all of these x's in here. So then our general term is going to be replacing x with x squared right up above. Squeeze this in here, minus -1 to the n. X now becomes x squared raised to the 2n divided by 2n factorial. And so our general term down here is the same thing, -1 to the n, x to the, and then the power up there is 4n divided by 2n factorial. And I think that's it. That's our general term. It's the last thing we just wrote. So then if we wanted to write it in summation notation, it doesn't say that we need to, but we could write that cosine of x squared is equal to summation of the very last thing up there in black, -1 to the n, x to the 4n divided by 2n factorial. And then we just need the starting and ending. Well, this goes forever, so up to infinity. What value of n can I plug in so that I actually get a 1 as the first term? Well, the only way to do that is to make a 0 up here on the power. So we're going to start at n equals 0.